Well, thanks everyone for having me here today, and I'll be presenting on developing a treatment method for invasive mussels, protecting Alberta's irrigation infrastructure. As you've heard, my name is Brad Calder, and I've worked for the water quality section of Alberta Agriculture and Forestry. Now, our research team includes Ivan Friesen of the Eastern Irrigation District, as well as Andrea Kalischuk, Barry Olson, Nicole Seitz-Vermeer, Lloyd Healy, and Key Au of the Alberta Agriculture and Forestry. Now, our more exciting title of this presentation is Zebra Mussel Tussle. And as you can see here, you can see the zebra mussel and the quagga mussel. Now, the invasive mussels are a huge concern to Alberta. And as you can see, the quagga mussel, which is 5 centimeters in size at maturity, and the zebra mussel, which is about 3.5 centimeters in maturity. Now, they appear very similar, and generally they're very similar to the effect they would have on our irrigation infrastructure. They prefer calcium concentrations of greater than 25 milligrams per liter and a pH range of 7.6 to 8.6. Now, this is a concern for Alberta as well, as our water conditions are within this range. Now, another example of the invasive mussels is this here, and I'll have that sitting on the table. And this is a piece of ABS pipe that was submerged in Lake Mead for a period of 7 months. And so you can see they accumulate quite rapidly on a variety of substrates. Now, the invasive mussels were originally introduced to the Great Lakes in the late 1980s and have since then moved across the continent. As you can see, they've followed the flow paths of rivers as well as arrived spontaneously at many locations, and we believe that is due to boat traffic. Now, that's a concern for Alberta as our borders are open to boats coming in and out, and with those boats, there can be invasive mussels on the boats. When those mussels arrive in our water bodies, they release their eggs and they will multiply within our water bodies. Now, they're currently in Ontario and Quebec, as well as Manitoba, and I'm sure you've all heard of Lake Winnipeg, the abundant mussels on the shores. And actually, it's so severe in Lake Winnipeg that the mussel shells are washing up on the shore and to the top of people's boots. Now, these are razor sharp and can perforate into your feet. So it really affects the recreational users of that water body. Now, we're working conjointly with Alberta Environment and Parks. They're working on prevention, which includes the boat inspections, pull the plug, as well as clean, drain, dry. And I'm sure many of you have been stopped at the boat inspections while moving your boats around the province, and it's a bit of a delay, but I can guarantee you that it's important, and it prevents us from spending a lot more money in the future. Now, Southern Alberta really is irrigation. We have $3.7 billion invested in the infrastructure, which includes 57 reservoirs, about 4,000 kilometers of canals and pipelines, and other specialized structures such as control structures, pumping, and pumping stations. Now, this supports our agriculture industry as well as communities or municipalities, and has environmental relevance as well as it supports wetlands. I'm sure I don't have to tell you guys about the geographic range of our irrigation infrastructure. It stretches north of Calgary down to the US border and across the width of our province. This is a very large area, and many kilometers of infrastructure could be negatively impacted by the mussels. In addition to our work with Environment and Parks, we also conduct the monitoring at 22 high priority reservoirs. Now, these are deemed high priority because of the boat traffic they see throughout the year. And as you can see, there's 13 reservoirs in the Old Man River watershed and 9 reservoirs in the Bow River watershed. So the monitoring of those water bodies, generally we go out and simply collect a plankton sample, and then we send that to Alberta Environment and Parks to analyze it for the invasive mussel villagers. Now the villagers are the juvenile forms, and it's important to note that they're microscopic. So you could be bringing water into the province in your boat and be bringing mussels with it and not even know. So to prepare in the event that mussels find their way into our province, we are currently looking into chemical control options to treat the pipelines. Now, to treat the irrigation reservoirs, we believe at this time that it may be too costly due to their large size and the fact that they're flow-through environments. So necessarily to treat them to a target concentration, it's just not feasible. So we're looking into chemical control options for the irrigation pipelines. Now, as the irrigation infrastructure develops and continues to develop and it continues to modernize with the installation of pipes, we'll see an increase in the number of pipelines that we have in our province to move that water. Now, to treat those pipelines, it isn't very simple because thermal vibration treatments won't work. Pipeline coatings will take a large time to recoat all the existing infrastructure, as well as pipeline pigging isn't necessarily an option because the irrigation pipelines reduce in size the further it gets, the closer it gets to those farms. It's important to note that there's currently no chemicals registered for use in Canada for the treatment of invasive mussels. Now, we're working with Environment and Parks to register potash as an option, and so we're currently working on that. The reason we chose potash is because it works on the invasive mussels as an anesthetic, so it prevents them from completing respiration, so they essentially drown. It's naturally occurring, it's essential for plant and human functions, and it's available right next door in Saskatchewan. So it's close and it's commonly used as an agricultural fertilizer. It's also been used in Manitoba to treat water bodies as well. As you can see here, that's one of the boats that were used to treat the various harbors of Lake Winnipeg when they had a mussel problem. Now, they treated those bays, however, by the time they actually did the treatment, those invasive mussels moved away from the bays, contaminated the entire water body. So unfortunately, they moved back into the system. NOAA Research is a 2-year project. It's to develop and test the potash preparation methods. So to create that solution of potash that we can actually inject into those pipelines at that concentration of about 100 milligrams per liter. And that was done just simply as a research concentration. Until we have mussels in our province and we can do a toxicology study, we can't necessarily say for certain that that concentration will treat them. This research was also done to document and assess the irrigation of potash water onto soil and crop health. And we're also working to confirm the economic costs of these treatments through an outside contractor. I'd like to acknowledge our research partners, which includes, of course, Alberta Agriculture and Forestry and the Eastern Irrigation District. I'd also like to thank the other irrigation districts of our province, which we work conjointly with to develop these treatment methods. Growing Forward 2 and Alberta Innovates provided funding to these projects, as well as the Alberta Irrigation Projects Association. And we're working conjointly with Alberta Environment and Parks. Now, our field trials are really our field trial methods. They involve the injection of that concentrated potassium solution, which we developed by mixing agricultural potash with just regular potable water. And that was done, and it was filtered until it was a clear solution. We then injected it using a dosage pump, which is something that's generally used in water filtration plants or, say, large swimming pools. And that was done. That solution was injected into the vertical breather pipe of these underground pipelines. Now, to inject that at the proper rate, we had to monitor the flow rate moving into that pipeline as those downstream pivots were operating. So by injecting that solution, we allowed it to mix with the water within the pipeline to that target concentration of 100 milligrams per liter. Now, as we have the downstream pivots turning off and on, there are some fluctuations in the injection rate. Now, our first field trial was conducted in 2016. This was done in the Eastern Irrigation District at the 15 East Branch Pipeline, which is southwest of Brooks. Now, this pipeline was provided water to a single pivot, so it was quite a simple study site to start off. There was a settling pond which supplied water to the pipeline from the canal, and that pipeline supplied water to that single pivot. Now, during the injection procedure, we of course had to operate the downstream pivot to have water flow throughout the pipeline, and we conducted monitoring at that settling pond to make sure that that water wasn't flowing back into the settling pond. As you can see, this is our steady state injection pump. Now, in 2016, we had some problems with our dosaging pump we selected, and so we had to modify our procedure and use the steady state injection pump. So generally, we started up the downstream pivot and conducted that injection, and of course, we monitored the concentration of potassium along the pipeline to see that increase. And what we were specifically measuring is electrical conductivity. So we were quite successful with our first field trial. We had that increase to that target concentration, and we held it in the pipeline for a period of 48 hours and discharged it following that time. And as you can see from the graph, we have the potassium concentration along the y-axis and the days along the x-axis. We also conducted soil monitoring to assess the change in soil chemistry following that application of potash, just to make sure that we weren't negatively affecting the soil conditions on that agricultural field. It was canola at the time of the field trial, and we conducted soil sampling down to 15 centimeters, as well as a topsoil sample from 0 to 2.5 centimeters. Now, as you can see, the potassium chloride and electrical conductivity graphs are shown here with the milligrams per kilogram and electrical conductivity along the y-axis. And we have the pre and post following that application of potash to the land. And there was not a significant change in that 0 to 15 centimeter soil depth. So in summary, we were quite successful at injecting to that target concentration. We didn't have any leakage into the settling pond, and the 0 to 15 centimeter soil sample was not significantly affected. However, the topsoil had a significant accumulation of chloride. So generally, with that application of that potash-treated water, we applied about 74 kilograms of potash throughout that trial, which is about 39 kilograms of that potassium ion. Now, that was irrigated onto the agricultural field at 5.5 millimeters, which equated to a 7.9 kilogram per hectare application of potassium. Now, generally with the canola crop at 2 tons per hectare, they'll remove about 17 kilograms per hectare of potassium. And in comparison to an application of beef manure, which is quite a bit more than that application. Now we continued our field trials into this year we continued at the Eastern Irrigation District. Now we selected 2 pipelines which were supplied water by a single settling pond. As you can see in the figure there, settling pond is located adjacent to the canal, and it supplied water to multiple agricultural fields. Now we had 3 landowners which agreed to participate in the field trial. So it was a bit of a step up from 2016, as we had three pivots to deal with. And it was about 4,000 meters in length, the pipeline, at 840 meters cubed. Now we injected that potash solution at a reduced concentration, really to meet our needs with the injection pump. And we injected 1,500 liters, and we attained that concentration of 102 to 107 parts per million. So we overshot it a bit, but it was good data to have. And it was about 2.7 hours to complete that injection. Now, our landowners were critical to this field trial, as they operated the irrigation pivots, and they worked with us very well to turn off and on those pivots at the times we needed. With those pivots turning off and on, we of course had to change our injection pump to that required flow rate. Now, we originally planned to conduct the 2 field trials within the EID in quick succession. However, as many of you know, the weather doesn't necessarily always cooperate. So we continued with the field trials June 20th to 21st. Now, in this field trial, we just decided to hold the solution in the pipeline overnight, as the agricultural producers, they had plans to apply a herbicide the following day. So we had 2 irrigation pivots on our second field trial. We originally planned to have 3 pivots. However, we lost a landowner as he had some work to do out of town. This pipeline was 3,000 meters in length, and we injected about 1,000 liters of that solution into the pipeline. We obtained that concentration of 87 to 99 ppm. So it's good data to have, and we believe that in the future, if this potash treatment is ever done in our province, that there'll be a range of concentrations that we can achieve. It took about 2.5 hours to complete this injection. Now, following our field trials in the EID, we updated our procedures and streamlined our process a bit in order to undertake a more complex field trial. Now, working conjointly with Taber Irrigation District, we identified a pipeline which we would be able to treat. However, due to, of course, the growing season, everyone's busy out in the field, we decided to plan it for September 12th to 13th. Now, we worked with 8 irrigation pivots and 1 wheel line, so it's quite a bit more complex from what we worked on in the past. And that's 6 landowners in total that we worked with. Now, this pipeline was 7,000 meters in length and about 2,900 meters cubed in volume. So quite a bit step up in terms of the pipeline size as well. We injected 3,600 liters into the pipeline, and we actually overshot our target concentration by 20%. Due to the needs of the landowners, we just held that solution in the pipeline overnight, as we recognize everyone's busy, and we want to work conjointly with the landowner so that they're comfortable in what we're doing. It took 6 hours to complete the injection, and then to do the discharge the following day. Now, we continued that the following week, September 19th to 20th, in the SMRID, and working conjointly with the SMRID staff, which agreed to join us, and they were stationed at each of the pivots along with one of our staff members. Now, we turned on each of the irrigation pivots and completed the injection. We had 3 landowners and 7 pivots for this field trial. And the pipeline size was similar to what we worked with in the EID, however, more landowners. So it's good data to collect. And we injected about 2,800 liters of that solution into the pipeline. We adjusted the calibration of our equipment following the TID trial, so unfortunately we didn't attain that target concentration, but it was good data to collect. It's quite a bit faster on this field trial in terms of completing the injection. It took an hour and a half, so it required us to be very well organized and centered at each of the pivot. To further fulfill our research obligations and complete our objectives, we worked with the small plot study at the Irrigation Technology Center in Lethbridge. This was located on a single span pivot, and we had 12 plots centered around that pivot base, and we completed 3 treatments of potassium chloride to that agricultural land. We grew a barley crop on that on all these parcels. And we did 4 replicates with 3 applications per year. We started in 2016 with applications of 0 ppm, 100 ppm, and 500 ppm. However, after the 2016 season, we deemed that the 500 ppm it would be far greater than we would ever apply in a treatment scenario. So we decided to simply apply irrigation water to the 500 ppm plots to measure their response to that continual application of that irrigation water and the response of the soil conditions. At each of the plots, we conducted soil sampling for pre-treatment as well as post-treatment for both years. Now, in summary, we were quite successful at injecting that potassium chloride solution at that target concentration and holding it within the pipeline for 24 to 48 hours. We did see that significant difference in the chloride concentrations for that topsoil. However, we have not yet reviewed our 2017 results. We're expecting lab results at the end of December. Our small plot study, we did not see any significant difference in the potassium concentrations. We did see a significant difference in the chloride and electrical conductivity, however, and we're still waiting on our 2017 soil results. Now, for the small plot, we did conduct tissue sampling in the end of this growing season, and we did not see any significant difference in the vegetation or tissue samples. In closing, I'd like to thank all of you for allowing me to come and present to you today, as well as I'd like to thank our partners. And would anyone have any questions? Yes.
You could be looking at sampling a little bit deeper for chloride. That may be part of why you're seeing that variability in 0 to 6 inches.
Yes, actually at the small plot this year, we sampled down to 1.5 meters. So we're still waiting on those soil results, but hopefully they give us some more information on our applications.
So would it be, like how often would you suggest that we're putting it into the pipeline? Like every time the water goes through it, or you don't do it twice a year? Or
No, so there's, throughout the United States, there's 2 reproductive events per year of the invasive mussels. So they'll release their sexual gametes and then form juvenile mussels, which will settle out. So that happens twice per year, so possibly treatment once per year. However, working with our external contractor, they've identified that we might be able to simply freeze out the mussels in the pipelines by have fans blowing cold air and drawing down those pipelines as well. Yes.
So if we get those mussels in Alberta, you're going to give away free fertilizer?
No. I can't speak to any. I'd just be speculating on the future, but yes.
Does it have to be potassium chloride solution? Could it be hydroxide or acetate or anything like that?
So there's many different forms of chemical treatment you can do for invasive mussels. There's various forms of oxidizers or viral toxins which you can use. However, potash at this time seems to be relatively inexpensive compared to those options. So there's many different options to use. Oxidizers such as such as oxidizers may be an option as well. However, they would affect that agricultural cropland and the plants growing on it. Any other questions? Yes?
And no significant issues with the open canals and production then, is it?
Well, at this time, it's difficult to gauge the Mussel's effect on the irrigation canals and, of course, our dam infrastructure. I guess we could look to the states to see the problems they're dealing with, as well as out east. And there is problems with some of that specialized equipment. However, treating the reservoirs, we deem at this time it may be too expensive. The canals, we just aren't sure at this time. Excellent. Well, thank you very much.
Appreciation.